I can't have it register someplace else. I can't have it automatically be taken over by another gateway because it's a physical hardwired connection. It's still the old technology. So what we've done is we've taken these gateways and we've installed them in what we've determined as kind of like centralized points around campus, because every building, depending on the size of the building, this building may have 8 analog lines needed. This building might have 12. This one may have 3. Well, we don't want to buy a bunch of gateways that offer 24 ports and then have all this, all this spare stuff sitting there not being utilized. So we've installed these in here in Burkhart, in RB, in Neuer, because Neuer, even though we're no longer using that as our main communications area, it still is a centralized area that lots of outside cabling from other buildings runs back to. For the other side of campus, once you get past Bethel and over on Tillotson, we have gateways installed in Alumni. So we picked areas where either a lot of buildings have outside wiring from the building to that building, or from a building to another building, and that building connects back to here, or back to that location. The nice thing about analog is that you can extend analog a long distance without any sort of signal degradation or anything like that. So what we did to test that before we started doing it is we put one of these gateways in the Robert Bell building, and we used a cable path all the way to like Scheidler Apartments to see how, which is further than we plan on extending it, but we wanted to make sure that we could extend something very far and it works. So that allows us to use this kind of centralized approach instead of putting this equipment in every room or in every building on campus. We also have what's called a unified border element, which is this item right here. It's called a cube. The cube acts as a session border controller, or think of it as a gateway between the communication manager and other stuff that's not communication manager. So this border element right now is providing PRI-T1 interfaces between the Cisco solution and the Avaya solution, so that we can place calls back and forth between the two systems. That's important because when we move your phone from the Cisco or from the Avaya to the Cisco, we wanted it to be transparent to everybody else on campus. We didn't want to have to start assigning new phone numbers. We didn't want to have to start publishing 2 numbers for everybody. So in order to do that, we had to make sure that there was a talk path between the two systems. We also had to do that because all of the primary trunking, or all the primary connections to the public switch telephone network, those still reside on the Avaya system. So in order for a Cisco phone to be able to reach the outside world, the call has to be able to go from the call manager to the Avaya and back out to the PSTN. Now, we're in the process of developing an RFP so that we can migrate from the PRI-based connections to the PSTN to a SIP-based connection. And what we plan to do is take those SIP trunks, take your commodity internet bandwidth, and get all that from one provider, have a redundant connection here and an RB, so that if one goes down, you still have another connection. You don't want all of your voice connections in one area, because if that area goes down, then no one can reach anyone on campus.
So eventually then that piece will go away when all this goes away and you get into a full SIP environment?
No, this will. What the cube does in that environment is the cube acts as a session border controller. It is the thing that you tell your SIP provider is the gateway to your network, is the gateway to your voice environment. Because what you don't want to do, back when SIP first started, what a lot of people would do is they would just take a connection to their voice system and they'd hang it out there on the internet and tell people, hey, you know what? Let's network all of our telephone systems together. Here's the IP address for our phone system. Give me the IP address for yours. Well, that was cool until somebody else on the internet figured out what your IP address was, and then it started injecting SIP calls, because unless you use a session border controller or something that controls what is trusted and what is not, then all you got to do is just engineer a SIP packet, inject it into that person's connection, and now you're placing calls either through their system or out of their system onto your long distance traffic or your long distance connections that you're paying for. So the session border controller, or the cube, will function as the controller. It'll be when we set up the SIP trunking, we will give the SIP trunking provider the information for our cube. They will give us the information for their session border controller, because they're going to have their equipment protected as well. And so that's how we're going to control whether or not something is trusted. Let's say that we decided that we were going to provide free calls to IU, to anybody that anytime they want to call Muncie, or they are going to give us free calling anytime that we call Bloomington. Well, we would use the same concept. They would interface with this. This would be the gateway that they send all their calls to, and then they would have a session border controller on their end, I assume and I hope, that we would send all of our calls to. That way, there's a way to trust that call, to make sure that, whatever comes from that place, I'm going to trust and I'm going to route across my network appropriately. We have 2 of these in a hardware redundant environment, so that if this one goes down, we have one in RB that takes over. One thing that I failed to mention on our the Unity connection server and the present server is that those are in a software and a hardware redundant environment. So we have a primary and a secondary on both. So if the primary on either one goes out, then the secondary immediately takes over. It's always mirrored, so it should be a pretty seamless transition to where nobody would even notice that happens. So the cube provides a gateway to the outside world, but what about those folks that are using Jabber for telephone calls when they're off campus? If they're on campus, they're behind the firewall, they just use the Wi-Fi network to get back to the call manager. When we started this solution, if you were off campus and you wanted to use Jabber, you had to start up a separate VPN session so that you would have a VPN connection back to campus. Then you could start up Jabber. Well, we held off on doing that a whole lot, because what we found is that laptops, yeah, that's not a big deal. It's pretty standard to do a VPN connection. But tablets and smartphones, oh my goodness, was it difficult. Not only to get all of the clients to work correctly, but to get people to understand. You can tell somebody this is a VPN on your laptop. Oh, okay, I understand that. Well, now you got to do a VPN on your phone. And what? It's the same thing, but people just had a hard time grasping it. So what Cisco did is they came out with a product that they call the Expressway. And what the Expressway does is the Expressway sits outside the firewall, and when you start up Jabber, Jabber's registering with that Expressway. The Expressways are configured in pairs, so you have an outside Expressway and an inside Expressway. So the Jabber on the outside or on the internet, or Jabber from your home, never physically connects to the call manager here. You connect to the outside Expressway. That Expressway then sends the call over to the inside Expressway, and then that Expressway routes the call to the Cisco call manager, and then the call manager determines whether or not that stays within the network or goes out to the PSTN. So that allows us to provide that functionality of having your Ball state number on your smartphone without you having to do anything but just activate it.
And so are all the numbers programmed in that outside expressway so it knows to accept something coming to it?
It is all integrated within the Jabber product, within the Jabber suite.
Okay.
So it knows based off of the information that it's got. It knows just to go back there, and really the expressways don't do any routing themselves. They just know that when a device registers, I'm going to send it to here, then I'm going to send it to here, and the call manager is what actually looks at the numbers and items that were dialed and determines where that call needs to go. So because we are trying to promote this mobility and promote being able to use this service from anywhere, we have 2 outside expressways and 2 inside expressways. That way we have physical redundancy in case one goes down. People will still be able to utilize Jabber from off campus.